Hello and welcome to today's webinar, MongoDB Best Practices for Reporting and Analytics, featuring Estuate and Logi Analytics. My name is Alvin Wong, a Product Marketing Manager at Logi, and I will kick things off with an overview of the two companies. At Logi, we have a vision that is embodied in a concept we call analytics everywhere. We believe in the democratization of data and empowering more people across the organization to be data conversant. By getting information into the hands of more people in an intuitive manner, companies are able to establish operational transparency, which in turn enables more informed decision-making. Logi Info is our business analytics platform that we will see later on. Info empowers technology professionals to rapidly create dashboards, reports, and self-service analytic capabilities deployed as either standalone applications, mobile applications, or embedded inside of existing applications. Our product suite delivers on the true promise of data analytics, allowing people to intuitively access, explore, and share information across organizations and with external stakeholders, and not just in a conference room with data scientists. The company has experienced rapid growth, growing over 600% in the last 5 years, and serving more than 1,200 customers. Based in the U.S., we have also international offices in the UK and Sweden. We work with companies of all sizes, large and small, across all industries. You will likely recognize some of the logos that you see here. We are joined today by our partner Estuate. Estuate is a global IT services company founded on the simple premise that clients value a partner that is both technically proficient and highly responsive to their needs. Headquartered in Silicon Valley, the company has offices in Canada, the UK, and India. Estuate has a strong expertise and an established track record of successful engagements in cloud computing and big data across a wide variety of technologies. As a result, they are a trusted advisor for a number of companies, from startups to Fortune 50 companies. In a recent survey we conducted with more than 400 software providers and SaaS providers, we asked these providers what data sources they have already deployed and they plan to deploy. And this is what we found. I think obviously relational databases, data warehouses are most prevalent today, but we also tried to gain some insight around the three top categories or the emerging big data types of technologies, and those being NoSQL, such as MongoDB, analytic data stores, including Columnar, like HP Vertica and Amazon Redshift, and Hadoop, right, from providers such as Hortonworks and Cloudera. And what we see here is that the growth and usage and the implementations are still emerging, but also growing as well. So even though you'll see here that NoSQL implementations exist at about 14% of software providers that we surveyed, we can see that of those three types of technologies, in the next 2 years, 20% of providers will have used some of these new technologies in their applications. And what we also found was most of these applications do have analytic capabilities inside of them, embedded inside of these applications. And as such, that's what's actually driving this particular discussion today, where we're going to focus in on utilizing MongoDB for reporting and analytics. And join with me in this discussion today is Sri Krishna Himakunthala, who is a senior DBA and big data consultant. Sri has about 20 years of experience in databases, relational as well as NoSQL and big data technologies, and he's joining us from Estuate in this session. We also have Tosin Ajayi, who is a senior solutions engineer with Logi Analytics, and he will later on in this particular session give us a demo of Logi Info working with data from MongoDB. And again, my name is Alvin Wong. I'm a product marketing manager here at Logi Analytics, and I have so what we're going to do here is actually a number of different things. But before we get to the topics at hand, I just wanted to share with you a few programming notes. This particular session is being recorded, and we will share those with the folks who have registered with us. We also will have the slides made available to you as well. And feel free during the session to enter in questions in the bottom right-hand corner of the WebEx window there, and we will address those during the Q&A session at the end. And so the first thing I'd like to do, in fact, is invite Sri now to give us all some insight into the popularity of MongoDB and why application providers are choosing MongoDB as their application backend. Sri?
Hi, thanks Alvin. Hey, good morning or good afternoon everybody. Hope you're all having a nice day. So before we jump into the details of the MongoDB, what exactly is MongoDB about? So it's a leading NoSQL big data technology, and MongoDB is a document database. The advantage is that the documents map nicely to programming language data types. Also, MongoDB dynamic schema makes polymorphism easier, and so there is almost no maintenance or very minimum maintenance because of the way Mongo is structured and because of the facilities that MongoDB gives. Okay, the advantages being that you can achieve very high performance using MongoDB because MongoDB has facilities such as sharding and replication, which will give you very high performance and scalability of read writes, and also the high availability. And the high availability is also orchestrated through these replica sets that are being offered in MongoDB. And so MongoDB is a perfect choice for most of the analytics applications.
All right, great, Sri. Now, to a lot of Sri's points, we see that MongoDB usage is growing among application providers. But at the same time, a lot of the attributes for MongoDB, for many of us, we might actually not think to be optimal or ideal for reporting and analytics. So, for example, fast writes, whereas reporting and analytics likes to have, fast and efficient reads of data. MongoDB also supports a dynamic schema as well. And it's also document-oriented, which means that, data is not really stored in a table format with columns and rows. And of course, columns and rows are kind of what you typically, think of when you're thinking of putting together a tabular report, for example, as well as creating some type of visualization. So given that, that's really why we have this session today. And what I'm going to ask Sri now to do is actually go into, from his point of view, and really just share with us the top 3 attributes about MongoDB and those 3 best practices, best approaches for utilizing MongoDB for reporting and analytics.
Yeah, in fact, MongoDB for reporting and analytics, there are 3 major things that are available in Mongo that will make Mongo the best choice for reporting and analytics. First is the architecting based on the consistency requirements that we have. And second is the embracing of denormalization and embedding of the documents and arrays that Mongo offers. Mongo offers lots of features where you can embed multiple levels that will enable you to present your documents in a hierarchical format very easily. And so, and also the denormalization, the way it enables you to denormalize your data so that all your data stays together. That way your readings will be a lot faster and you get all your data required from a single source and so on and so forth. And the third is like very elegant built-in querying capabilities that Mongo offers. And in the subsequent sections, we are going to talk more on these, more details on these 3 things as such. So here I'm presenting a typical system architecture for an analytic system, the architecture of the Mongo for an analytic system as such. as you can see, the 3 boxes of MongoDB, which is basically a sharded MongoDB. That means all 3 of them together will make our total data set, or in other words, our total data set is distributed on 3 different places. And second, on the left-hand side is lots of data sources from where the data is being fed into the MongoDB, and also on the asynchronous writes that MongoDB supports. Because of these asynchronous writes, you will have lots of write scalability where you can write terabytes of data in the fastest way possible. And also the spreading of the writes over multiple shards. So because of the sharding, your writes will happen not just on one, it will happen on all of these shards, as many shards as you have. And so you can parallelly write, and so your write scalability will be amazing, especially in analytics. We deal with terabytes of data. And all these writes are buffered in the RAM, which means that subsequent reads will be carried out from the memory, and so which will be like very fast and super performant. And another feature that I love about Mongo is the upserts. These upserts generally avoid the unnecessary reads. Upsert basically is that, let us say, you have a business case where you're trying to see if a particular salesperson is there in the database or not. And in a relational world, you'll go, you run a query, you check if the record is there or not, and if it is not there, you're going to insert. If it is there, you'll run an update statement. Whereas in Mongo, in a single upsert statement, you can achieve all of this functionality. That means replacing 3 different statements in a relational world with a single upsert statement in Mongo, which will make it very elegant for pre-aggregations and so on and so forth. And in fact, yeah, the shard is basically like a partitioning of data. We presented 3 partitions. That means your total data is distributed onto 3 different hosts, each of them called a partition or shard. And so your data is distributed onto multiple hosts powered by the respective processing power and memory and so on and so forth. And so you are scaling out enormously and very nicely as such. So getting into the first bullet point of handling of consistency, and in general, Mongo is an eventual consistency. Let us see this diagram here. MongoDB in the middle, you have the primary. On the left-hand side, you have the secondary one. On the right-hand side, you have the MongoDB secondary 2. And whenever you write the data to your primary, the transactions are replicated to the secondaries. And so secondaries might have some small amount of lag. And this is what is so-called eventual consistency. That means your secondaries will be eventually consistent with your primary. And this feature can be helpful in majority of the cases. Let us say for write scalability. Say you have some reporting need where you don't need like up to the second of the data. And so you can redirect all your reports onto the secondaries in such cases, so that you're achieving read scalability by utilizing these eventual consistent replica sets as such. And there are also other advantages outside the reporting world as well, such as say some bad data gets into the database on the primary, and because you have a lag on the secondary, you will be able to identify, and so you can correct that data by taking uncorrupted data from your secondary and repairing it on the primary lag. So this is what the read consistency is. And so the point here is that all the time sensitive reads will be directed to the primary, and non-time sensitive reads will be directed to the secondary. That means you have more than one host servicing your read requests, and so you are achieving amazingly great read scalability out of this architecture. And also, what other options do we have as far as this read preference is concerned, like, or how would I say read from primary versus secondary like? So this is what is so-called read preference in Mongo's world, that you specify on the driver side. Say the first, in fact, Mongo supports 5 different types of read preferences. The first is the primary. If you do not specify anything, by default it reads from the primary. And the second is the primary preferred, where the reads will preferentially be carried out from primary. If the primary is not reachable or not available because of whatever reason, then it will go to the available secondaries and read from secondary preferred, and nearest network, or other choices or options that we have in setting up how our Mongo should read as such, which makes Mongo very elegant and very congenial for an analytic application as such. So let's take it to the next slide. So MongoDB for reporting and analytics. So as we discussed, we need to architect our analytics system in such a way that we are utilizing all these reading from secondary options, so that our reads are very optimized and our I/O is distributed. Second, before we delve into the more details, I want to take this opportunity to give some idea of how a MongoDB data model looks like, or what it exactly contains, in fact. So the MongoDB instance basically holds a bunch of databases. This database is very analogous to the databases of the relational world. And a database generally holds a bunch of collections. That means collection is equivalent to a table in the relational world. A database can have a bunch of so-called collections, and the collection can have a set of documents, and a document will have a set of fields as such. Each field basically will be a key value pair. Key will be like a string, as we have depicted in this example on the JSON model. Employee number, EMP name, e-name, these are all field key names. And on the right hand side is the value separated with a colon. This is the key value pair presentation. And let us see a typical relational model of the HR. Let us say you have a department table and an employee table and one-to-many relationship and a referential integrity and so on and so forth on your left-hand side. The same thing on the right-hand side in a JSON model. You can present all of them together, which is kind of denormalized, and all the data is at one place. And let us drill down more into these things, and a couple of examples I'm going to show you. So let us say in the relational model you have a new employee, as you can see in my previous slide. Here, the employee name is a 10-byte variable character. That means if an employee with a bigger than 10 bytes or characters joins us, the relational model probably needs to change. And also, let us say your business changes slightly, and your HR decides that every department be prefixed with a department short code, such as ENGG for engineering or OP for operations. Like that means basically, in short, it is a data type change in relational databases. And such changes, if happen, your business model considerably changes in the relational world. And the same thing, if you see in a MongoDB world, MongoDB, you do not define any data type per se, and also you do not define the data length and so on and so forth. That makes it very congenial for all these types of changes, and it brings in lots of agility and also this denormalization, so that all of them are at one place, and so you don't have to necessarily, or you don't have to really join any two collections in Mongo world. And these joins are very expensive, believe me. They are the force of scalability and analytics as such, especially. And so because of all these salient features of this MongoDB, it is like ideal for changing business needs, and especially in this world of agility, where agile and Scrum practices are very prevalent. MongoDB is an ideal solution for analytics and other types of applications as such. Also, on the left-hand side, if you see, let us say an employee splits his time between two departments, say 50-50 between two departments. If it is a relational model, this one-to-many between department and employee will totally change, and so you have to totally revamp and re-architect your tables and any underlying triggers, procedures, packages. All these things need to change as well. Whereas in Mongo world, how it is stored, if you see, department name, sales and operations, which makes it like an array insertion, and so it is very elegantly handled as such, and the change, the schema is very dynamic this way. And on the right hand side, I have shown a denormalized embedded collection here with the department info embedded into the employee collection. And these types of hierarchical presentations also will enable Mongo to fetch your data in a minimum IO, with minimum IO. And so it is an amazing product for analytics and related applications as such. So
yeah, so as Sri is suggesting here, basically, for those of us who are coming from a relational world, you really require a different frame of mind when it comes to working with MongoDB effectively. Particularly, thinking about data and denormalizing data, because in this world here, relational types of joins are very expensive and inefficient. In addition, because documents are independent of one another and related information is read contiguously off of the disk, this translates to high read performance as well. So without having to define the schema when the data is written to disk, space is not necessarily consumed based on the schema. So that is, sparse data is better handled in MongoDB versus in other types of data stores. So that being said, I think all this really leads to now having the data stored as documents inside of MongoDB. That really leads into a discussion around the querying types of capabilities that MongoDB offers for you to retrieve data, as well as some of the built-in analytics inside of MongoDB that can be exposed. Great?
yeah. Okay, now we might ask the question, okay, MongoDB is great and good, all the good features, high availability and so on and so forth, but we are talking of an analytic application where the querying and pulling the data out of the database plays a dominant role as such, and people might ask like what type of capabilities Mongo offers as far as data querying and fetching and presentation is concerned. So we're going to touch a bit about these MongoDB data querying capabilities as such. So in general, let us say here I take the example of a zip code collection. I'm going to show how a find operation in Mongo works. A zip code collection is there with an ID field that stores the zip code, a city, a state, population, and the location, latitude, longitude. Like say you have a collection with probably millions of records into this one, and say if you want to get all the records or all the zip codes under the New York City, you will use a very simple find statement in Mongo. Find is very elegant, very easy to use in Mongo, and here is the syntax that we have shown. db.zip codes is a collection, and so the db.collection name.find, that is how you use the MongoDB find operation. And in the first curly brace, you are giving the query criteria which filters the data based on the city equivalent in New York. That means it gets into the zip codes collection, tries to get all the data where the city is New York. And in the second brace, you are selecting only the zip code column because you are not interested in the rest of the data that is stored in the MongoDB document along with the zip code. And it is that simple. This is very analogous to a select statement in a relational world. And this is very simple, elegant, and very user-friendly. Anybody with no technology background can as well digest this and start following to their advantage as such. And so very user-friendly notation that is offered here through find mechanism in Mongo. And this find will be very suitable for simple operations which doesn't involve very complicated aggregations and so on and so forth. And okay, what if I have to aggregate and do some advanced operations of filtering, ordering, and aggregating and whatnot? So Mongo has given a native aggregation framework for these types of aggregations. And aggregation framework, believe me, is an amazing facility given by Mongo. What exactly is this aggregation framework? So let us see what it is all about. This aggregation framework basically contains a series of operations or series of stages your data or documents pass through, where each of these documents is processed. This processing can be a transformation, can be a filtering, can be an aggregation. After aggregation, maybe another filtering, and then maybe a sorting based on a timeline or amounts or whatnot, dollar amounts or whatnot. And all these types of multi-staged processing that you carry out using your aggregation framework that makes it very easy and congenial, so that you are dividing and conquering, you are getting to your targeted state in stages, and so which is very amazing and simple. So you just divide your task into simple steps and then code for each of that, and they all work well together as such. And that is the beauty of this aggregation framework, and very easy. It's all built in. You don't have to know super JavaScript or anything like that, because these are all inbuilt functions in Mongo. The NEAT uses these native operations, and so very efficient. All this pipeline, these are all native to Mongo. These functions given in the aggregation framework are native to Mongo, and so very efficient as well. And in general, this is the preferred aggregation way, or the aggregation framework is the preferred methodology that Engine recommends you to use. And let us see an example of how an aggregation framework is carried out. So if you see, we have an orders collection here, which contains a bunch of data apart from the customer ID and an amount of the order and the status of this particular document as such. And you have a bunch of such collections onto the left-hand side. So in this aggregation, as I said, you carry out a bunch of operations. And here is the matching operation, where this data is fed to the matching function, and this matching operation will go and it picks up this filtering criteria of status equal to A, and so it filters out all the documents and identifies the documents with a status of A, and that is what matching basically does, and thereby your data set is reduced, or your result set is reduced, basically targeted result set. And then the second step takes this already reduced data as input and then tries to group this data. Let's say you have a 123 customer with a 500 amount and with a $200 order amount. And in this grouping, what it does is that based on the customer ID, it sums up all the order amounts for a particular customer, and then gives you the result set on the right hand side. And it is as simple as that. And all of this is a natively built functionality in Mongo. And you don't have to know a lot of any programming for this one as such. And such is the beauty of this aggregation framework, very simple inbuilt functionality, which is very efficient as such. So with that, the people might ask, what other options are available apart from aggregation framework to achieve these aggregations and complex rollups and so on and so forth. So let us see another way of doing or achieving the same thing. So Mongo also supports this MapReduce. MapReduce is another way. I'm going to address how MapReduce is different from aggregation framework in the subsequent slides as such. But to tell you briefly about MapReduce is also very similar, and you have a mapping stage where each document will be processed and it splits into one or more objects, and then this output will be taken as an input for the reduce phase, and then combines that output appropriately to give you the desired result. Probably when we see the example, we'll appreciate more of this one as such. So in MapReduce, the advantage is that you can write custom JavaScript functions and stuff, and these custom JavaScript will give you lots of flexibility that otherwise you will not be getting out of aggregation framework. And so this is very congenial for very complex aggregations and rollups where you cannot achieve or get your result through aggregation framework. And somebody might say, you know what, I'm an expert in JavaScript, I don't want to use or learn something different. For those guys, MapReduce will be very handy, in fact. Though the experience and the statistics prove that MapReduce is comparatively less efficient and a little more complex because you're supposed to know JavaScript functions and so on and so forth. So that being said, let us see how the MapReduce versus the aggregation framework. Oh, sorry, I forgot this MapReduce example. And here we have the MapReduce example, and we have the same orders collection and the same set of data. You see the number of steps that we have here, and in the first step, all the records of the orders is taken, and the query criteria given is the filtering criteria, and it filters down to the documents with status equal to A, and then all these documents are taken as input to the map process or stage. And in the mapping stage, what it does is that the MapReduce collects for each customer ID all the order amounts and puts it in the form of an array as such. And in the reduce phase, it sums up all these array elements and presents it in the form of a key value pair of the customer ID on the total value of the order for the customer as such. So this multi-stage process, and this is an example of a MapReduce, how the flow is processed in MapReduce. So here I just try to briefly touch base how or what is the difference between aggregation framework and MapReduce. Aggregation framework is the tangent recommended approach, being the native functions and everything, and so it's very elegant and efficient. It's also written in C++, and that also adds up to the aggregation framework being faster. And in aggregation framework, say whenever you're returning the result set after doing all of your processing, filtering, aggregation, sorting, and all of that, it will be returned as a JSON document presented as JSON, and that has a limitation of 16 MB max. And in the recent versions, Engine has accommodated returning your result set as a cursor, or you write your result set directly as a collection. And in these two ways of returning as a cursor and returning it as a collection, you're overcoming your size limit of the 16 MB when you return it as an inline return of the JSON or JSON document as such. And so you're no longer constrained in aggregation framework from the size standpoint, and very elegant and efficient. And you might as well say, you know what, aggregation framework is the best. It's all good, no limitations and everything, then why do we even need MapReduce, people might ask. And yes, MapReduce has its own advantage as well. So you have a very complicated aggregations and rollups and stuff that you need to do, and you need lots of functionality for that in terms of maybe the JavaScript or something like that. And because MapReduce accommodates custom JavaScripting and stuff, you'll have much more flexibility, and you can achieve very complicated use cases using MapReduce as such. And So hope it's all clear, and wherever possible, aggregation framework is the way to go, and wherever you need the flexibility that you cannot achieve through aggregation framework, wherever you need the complex processing that the provided aggregation framework functions are not enough or sufficient, there you go for the MapReduce, and that is how you sort out or orchestrate your plan of reporting using these frameworks given by MongoDB. And with these features, MongoDB is an ideal choice for all your reporting and analytic needs as such. And here I just present how it maps to a relational world, because majority of us might have started our early lives with the relational world. And so showing an example or how these functions map will be very handy. So generally a where clause where we are filtering the data will be achieved in the MongoDB aggregation framework using a match operator, and the group by clause where you have an equivalent $group operator in the MongoDB, and having is like you're filtering the data set or the groups as such, and that is also achieved through an equivalent match command here, and so on and so forth. And as you can see, it maps very well, and so it will be an easy task even for people who are coming with relational background to jump onto Mongo and start coding, because they nicely map some of these functions. And so it's very easy with a very minimal learning curve and very elegant functionality through aggregation framework and MapReduce and so on and so forth.
Great, thanks, Sri, for really giving those of us who come from the relational world that level of comfort that there's certainly a lot of built-in capabilities when it comes to analytics within MongoDB that can be utilized. The one thing I'd add on to that as well is to leverage these built-in capabilities from your data sources. Certainly only possible when in your reporting architecture, there is no ETL or some type of intermediate data store, sort of in the way that allows you to expose those analytic capabilities to you for reporting. So from here, what we're going to do now is actually pass it over to Tosin Ajayi, who will be giving us an overview of how Logi Info works with MongoDB.
All right. Go ahead and talk a little bit about how Logi Info works with MongoDB. So Logi Info is our platform. So I mean, to this point, you've heard a lot about about MongoDB, how it works, a lot of the capabilities that MongoDB provides, that it will support analytic capabilities. So what I'm going to do here is just kind of give you a little bit of information about Logi, how Logi works, and then we'll go into a demo of the actual platform to show you the concepts and the capabilities that Logi provides that allows you to leverage directly what MongoDB provides. So, a lot of our customers, they actually come with us with, several requirements to present visually appealing and highly interactive dashboards and reporting capabilities to provide to both their own internal users as well as their own customers, if that's the kind of business they run. What often happens and what they quickly find in using the Logi platform is that it provides the capability that allows them to cater to several use cases that they perhaps didn't associate with analytics, such as building out their entire web front end, which again goes back to the Logi Info's web architected roots, and I'll talk a little bit about the architecture in a short while. It also allows them to provide things such as information portals that enables them to provide mobile analytic capabilities as well as embedded analytics to their end users. And we have a lot of customers that actually operate in these different realms using Logi Info for a lot of the capabilities that it provides. So here is the Logi Info architecture slide, and it's really an overview. The Logi Info platform is a platform that allows you to create and deliver dashboard reports and other analytic content and capabilities to a wide range of end users, and they can be, the applications built in Logi Info can be deployed to either a .NET or a Java-based environment, that is a .NET or a Java-based application server, which can either be IIS on the .NET side or the wide range of application servers provided or available for the Java side. As a web-based deployment, which Logi Info supports, it allows you to reach the widest number of end users through consumption via a wide range of modern web browsers. You can also export content created to files as well as consumed on mobile devices, as mentioned earlier. Logi Info provides integration with virtually any data source out there. Your relational data source, big data source such as MongoDB, which we've been talking about today. Created applications in Logi can also be deployed to the cloud as well as deployed on-premise, whether it's in a physical or virtualized environment. You basically host and maintain these applications as you would any other web application. The Logi Info Studio that you see to the far right of the screen there, that's the development environment where a report author uses the concept of elemental design, which I'll show here in a little while, to design and create content that will be consumed by end users. Now, these contents, while created as a managed application, can be very highly interactive and even provide end users some self-service capabilities that we'll be going a little bit into today as well. All right, so now to so we've talked a little bit about this today, and to address that big data problem, a lot of organizations will pursue a wide range of data architectures, and for scalability as well as performance. So a lot of them will use MongoDB, and Sri has covered some of the reasons that you would choose MongoDB as well as the capabilities that it provides. It is obviously an industry-leading NoSQL database, as you've heard today. And it's particularly interesting because of the fact that it allows you to work with highly unstructured or semi-structured data. Logi Info provides native connectivity to Mongo, given the people who are interested in Mongo and Mongo enthusiasts the capability to work with Mongo using the wide range of mechanisms that MongoDB have provided and that the enthusiasts are familiar with, such as the find command, running different commands using run command that allows you to use MongoDB's aggregation framework, as well as using MapReduce, as Sri has talked about earlier. Now, it is not uncommon to have several MongoDB collections, your MongoDB collections to have several nesting, so you have hierarchical data. And this can often create a challenge when it comes to reporting and analytics. Logi Info provides a way that allows you to flatten and shape the data so that it can be easily analyzed and or visually presented. Logi Info also has a very robust processing infrastructure that allows you to directly integrate MongoDB and its capabilities into your workflow, as well as even facilitating things like database write back, and we also support such things with MongoDB. All right, so I'll go ahead and share my screen now, and I'll go into a demo to show you how Logi Info works with MongoDB. All right, so I will go ahead and bring up my virtual machine. All right, so what you see here is the Logi Info Studio environment. And before I go into that, what I'm going to show you very quickly are examples of applications built using Logi Info. As I mentioned earlier, Logi Info is our platform for building very robust web applications that provide BI capabilities such as reporting, analytics. So they can be entire web front ends, they can be directly embedded within the context of other web applications. And to that, I'm just going to go ahead and bring up just a couple of examples here. Here's an example of a dashboard, high contrast display, showing different forms of information. Now, you can have data for this dashboard, for example, coming from MongoDB. It can be coming from a relational data source, a flat file, web service. It can also be coming from, several different data sources at the same time. So, for example, perhaps you might have one panel in this dashboard showing information from a source and another showing information from a different source. Here's an example of a different application. Again, styled and themed differently. So as a fully web architected platform, Logi Info allows you to style and theme your application as appropriate. You can even apply your own custom style sheet, your own CSS, your cascading style sheet, as well as introduce your own web technology, such as introducing your own JavaScript jQuery into the application and facilitating the exact kind of functionality that you want within your application. That is, we don't tie your hands, we don't limit you in what you're able to do. We allow you to work within our platform in a code-free environment if you want to be that, to enable these kinds of functionalities. Let's just go very quickly into how you work with Logi Info. You heard me mention elemental design earlier. Elements in Logi are pre-programmed application components that you stack together to enable different functionality, whether it be plotting a chart, even enabling some actions or capabilities within the application, whether you want to facilitate things like a drill down and so on. So we'll go right into it. So for example, to create a new report, I can right-click on my reports folder and add a new definition. Definitions in Logi are stored in file system as XML files, which means they're very lightweight, very easy to deploy, and also very easy to maintain. So I'm just going to call my report here Mongo Find, and what you're going to see me do here is stack a number of elements. Now we have to the far right of the screen here what we call the element toolbox. Here I can start to stack whatever elements make sense for me. I can also use different wizards to stack these elements very quickly. So the wizard would just take me through a set of questions and stack elements based on the best fit answers that I provided to the question. Yeah, I'm going to show you the elemental design in its full flexibility. So instead of using the wizard, I'll actually just stack the elements by hand. What I've done here is just added a chart canvas, and I'm going to create a few things here. So again, I call this report Mongo Find, and as you can probably already guess, I'm just going to create a report that uses, or a chart in this case, that uses the Mongo Find capability. Let's go ahead and give our report a caption. Call it population, and I'm going to call it population using Find. And you see here, I have my attribute box that allows me to set several behaviors and attributes for my own chart. So let's go ahead and give it an ID. Elements in Logi, they have IDs, and you want to make sure that the IDs are unique so that your application works as expected. As a child of this chart canvas, you see that it's actually Logi Info Studio environment is very context sensitive. I see all the relevant element children for the currently selected element, as well as to the left bottom of the screen here, there's an information panel that gives me a good description of what that element does. So I'll go ahead and add a bar chart, and I'm just going to add a series bar here. Now, I'm adding a bar chart, and here's where I'm going to let my bar chart pull data. So Logi Info has a set of elements called data layers, and data layers really allow me to pull data. Essentially, it is responsible for acquiring and shaping data. You see, we have a wide range of data layers. We also have some dedicated specifically to Mongo. So I'm going to go ahead and use the one that uses the Mongo Find, and it just has a handful of attributes that I'm going to set here. So I'm going to go ahead and provide the name of my collection. Because I've already created my connection, I've already created a connection in my settings file for Mongo. I'll go and select that. It's called MongoDB sample, MongoDB sample DB. And the name of my collection is zips. So a lot of us are already familiar with the zips database. Now I'm just going to give it a maximum number of rows that I wanted to bring back, but I can also have it bring it back to max. Okay. Now, I can also create some grouping and sorting and filtering capabilities. Logi Info does provide some of those capabilities that allows for data shaping and data manipulation. Now, in this case, we'll go ahead and use that just to show you the functionality that Logi Info provides. Now, note that the grouping that I'm adding here is going to be performed within the application server. So for smaller data sets, you might be able to use Logi Info's provided grouping and sorting capabilities. But for larger data sets, because Logi Info supports a direct connect model, I typically advise that you use built-in capabilities by the underlying data source, because you probably have designed your data source appropriately to allow for these kinds of things. You want to leverage the capabilities provided by that. And I'm just going to go ahead and add a sort filter there as well, so that we have some sorting done. So I'm sorting by some pop aggregate column that I just created. I provided some, grouping capability, that we want to use and so on. Now I've created that. So because the data layer again is responsible for data acquisition and data shaping, I want to now tell my bar chart where to actually get its data from. So it's basically going to set a few attributes. I'm going to basically set my y-axis to the aggregate column that I just created, again, because we're creating a bar chart in this case. I'm going to give it an ID. I'm going to call it bar pop by state. And the x-axis data column, we want that to be state because that's what we want to show up on the x-axis column. You can also add other kind of capabilities in Logi, such as your quick tip, which provide the tooltip capabilities where you can, you have your hover over functionality. In fact, let's go ahead and do that very quickly, just so you see how Logi works. The quick tip row allows me to stack different messages as part of my tooltip, so I can fully configure this tooltip to show me whatever I want. Because the data that I want to display on my bar chart is going to be dynamically coming from my chart, we use tokens in Logi to allow us to capture different kinds of data dynamically within a platform. And because I want to show state, I'm going to call it a chart state, and then I'm just going to give it a text population. This is what allows me, tokens in Logi allows me to capture data dynamically within the application. And the value that I want to display there as well, I'm going to again get that from the chart. And the value is going to be some pop that we created as our aggregate column. And we're done creating our chart. Okay. I can also add something like a chart resizer to this, just to allow an end user to resize the chart within the browser. And this is really the concept of elemental design. If I click on the preview tab at the bottom of the workspace, it actually launches a browser environment within the studio that allows me to visualize what I just created. Okay. All right, and what we'll do now is we'll go ahead and do just that. Okay, there we go. Let's click on that preview tab, and it launches that browser. And as you can see there, we actually have our bar chart with the hover over capability that we provided, showing CA population. As you can see, that CA is dynamically populated, and of course, the population is dynamically populated. So I can hover over any of those bars, and you see that information. I can drag this out because we made it a resizable chart. I'm going to just, instead of building out these concepts, I'm just going to show you a few examples of pre-built content within the Logi info that shows you just the extent of what you can have within this kind of application. Let's go ahead and show you, another one that uses the run command. Okay. Give me a moment here. I'll show you an example of one that actually uses MapReduce. So you can use the aggregation framework. You can also use MapReduce. So we've created a chart here. In this case, instead of creating a bar chart, we have a heat map here that's showing, again, using the same concept where you actually use a data layer. In this case, we've used a data layer.mongo MapReduce, and it allows those different attributes as well that cater to that particular functionality. As Sri mentioned earlier, you can have a map function, and this is purely JavaScript function. I just expanded that attribute that shows that JavaScript map function, and that's our very simple map function. You can make this as complicated or as complex as you want, as well as our reduce function that also shows different kinds of capabilities that allows me to actually gather the result set of my map function and aggregate them for display. If you had a finalize function, you can also use that, depending on how you've written your own logic, specifying the collection as well as the connection that you want to use. Now, because the way this MapReduce function is written in Logi, it actually returns a hierarchical data set. So in fact, let's go ahead and run this and see what happens. Okay, now you see that we've run our result, report here, and we have a pretty flat, heat map as well as a table not really showing us any information. What I'm going to do here is just give you a sneak peek into the debugger in Logi to show you how Logi actually brings information back and also allows you to work with hierarchical data set. So I'm going to turn on our debugger links also with data. I'm going to rerun this report, and you see a little bug symbol show at the bottom of each of my visualization as well as the bottom of the report. Let's look at what the result set looks like. So we see the information. We can look at the JSON data right there. Let's go ahead and expand that. You see that we actually have the information available to us, except that value actually then contains a nested document that has information about the count and a total population for that particular state. Now, what that means is that that document is, that result set is hierarchical. So to fix that, Logi provides a flattener, which I talked about earlier. I'm going to add a flattener to that. which basically flattens the entire data set and allows me to present it as a flattened result set, which better works for things like plotting charts and displaying information in data tables and so on. Let's go and rerun that, and what you see now is our information looks a lot better. That looks more like a heat map, and of course our table now contains information both about the state and the count as well as the total population. So I've showed you just some of the capabilities that Logi provides. It also allows you to work with the aggregation framework using the run command, as well as it's also allowing you to use, to use database write back. And this is an example of a fully fledged application, again, built on the MongoDB ZIPS database that a lot of you out there are quite familiar with, facilitating or enabling things like interactivity, drill down. As you can see, it's fully styled and themed, as well as providing drill down capabilities, even that allows me to also use things like write back. So I can change the population of that to say 51843. Once I submit that, what you see now is that the population has been updated, and we can do that and so on. So Logi will provide a lot of capabilities. So let's just, running short on time, so let's just go ahead and do a quick summary here of things. So we finished the demo, and as a summary, Logi Info provides a full integration to a lot of different data sources using native connectivity, which allows you to leverage the built-in capabilities provided by the underlying data source, including support for things like read preferences, which you can in fact provide as part of the connection string. As I mentioned earlier, it allows you to use familiar concepts, and we talked about that earlier, as well as providing a code-free mechanism for shaping, manipulating your data, as well as even flattening it for the purpose of visual presentation.
All right, great. Thank you, Tosin. Let folks know that you can visit our website for additional information where you can actually see an extended MongoDB workshop as well. You can access the daily demo and also download the 2014 State of Embedded Analytics report with one of the charts that we showed you earlier in the day. I thank everyone for joining us today. Thank you.